which gives us a square root of 29. AB and CD are the same length using the distance formula. So line AB equals line CD equals the square root of 29. So the next thing they're asking you to do is do the same thing for lines EF and GH. So pause here, give that a shot, and come back when you're done. So line EF is 1 squared plus -5 squared, which is the square root of 26. And line GH is 4 squared plus 4 squared, which is 32. So EF does not equal GH. Pause here, have a look at the reflection question, and go ahead and do the your turn number 8, and come back when you're done. Reflection question number 7 asks you to understand the connection that we made at the very beginning between the Pythagorean theorem and the distance formula, where the x's are a squared and the y's are b squared, and when you add the squares and then find the square root, it's the same as a squared plus b squared equals c squared. And however you put that in language works for me. Your turn number 8, line JK has a distance of the square root of 13, and line LM is also root 13, so JK equals LM. Next, we're going to find the midpoint. For part 3, we're going to look at an easy way to find a midpoint. A midpoint divides a segment into 2 equal segments, so it's the halfway mark. A segment bisector is a line, ray, or something else that passes through the midpoint of a segment. So the segment bisector is what divides the line in half. So when we're looking at a line, I've got here line segment PQ, and line segment PQ is bisected by line L at its midpoint. So this M is the midpoint, and I've put little tick marks on line PM and line MQ to indicate that these are the same length, but they are not the same length as this. If L was also bisected, meaning cut in half, then we could do double tick marks there, saying these two are the same length, but not the same length as that one. So these are just little shorthand indicators you can use. Now, the easiest way to find a midpoint on a line is actually to fold a piece of paper in half. So we've got a piece of paper where we can easily see the A and B, and we're going to fold it so that the A and the B overlap, and we fold it right there, and ta-da, there's our midpoint. Right there, M for midpoint. But we're also going to learn a way to do it mathematically. So please have a look at page 11. Example 3 shows you how to fold something in half and mark the spot. And you look at it a little bit and you go, I can do that. You look through reflection question 9. How could you make this into 4 segments? Well, I could do it again, and I would have a mark there and a mark there, and that gives me 4 parts to my line. Ta-da! And your turn number 10 asks me how I can check it, and I would check it with a ruler. And then we're actually going to get to some math. Finding midpoints on a coordinate plane. The midpoint formula, if you remember from last year, is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It's the average of the 2 x's and the average of the 2 y's. So if you've got a point here and a point here, and you find the average height and the average distance, actually it's the other way around because this is x and this is y, that's going to give you halfway across and halfway up and down, and that's going to put that right in the middle. So using the midpoint formula on a coordinate plane is exactly how you get your midpoint. So they're going to walk us through line PQ. PQ has the coordinates -4, 1 and 2, -3. So if we stick these x's and y's into our midpoint formula, we're going to find that our midpoint is -1, -1. And it's going to ask us what quadrant it's in, remembering that you always start in this positive zone and you work your way counterclockwise. This -1, -1 puts us in quadrant 3. Okay, pause here for a moment and try B, and then your turn numbers 11 and 12. Come back when you're done. Our S points in the midpoint formula give us a 0, 2. The X coordinate is 0, so it's actually between coordinates 1 and 2. And then your turn. The midpoint of this set is 0, 0. And we've shown that mathematically. The midpoint of this is 1, -2. And so we've shown mathematically that it shows up in quadrant 4. Now, those are 3 very different ideas that are all part of section 1, lesson 1 in module 1. What I'd like you to do is take a moment to look over the elaborate questions, because those tend to look at the deeper ideas behind that. Pause here and come back so we can talk about them. For number 13, if x or y is the same, you only have to subtract the other coordinate. You don't have to go any farther than that. Number 14 is no. It doesn't matter because you're subtracting, you're either going to end up with a positive or a negative number, and then you're going to square it. So it doesn't matter if it's positive or negative. Number 15 is yes. Number 15 is yes because you're adding. It doesn't matter if you add 1 and 2 or 2 and 1. Order doesn't matter. And number 16, I would use a ruler for one, and I would use a distance formula for the other. So your homework starts on page 13. You're going to do numbers 1 through 8 all, and 9 to 15 odd, and 17 to 22 all, and 23 to 27 odd, and 28 to 30 all. And these last 3 are worth double points. So please be thorough with them because they're more in-depth questions. Okay? Please make sure you ask any questions if you have any, and I will see you next time.